Hi, good afternoon, everybody. My name is Sarah Monteleone, and I'm president of CGNA. Welcome, and thanks so much for joining today's webinar. Just a few housekeeping items before we begin. All attendees, please mute yourselves. The webinar will be recorded and made available on demand, found on the CGNA Exchange. There will be a Q&A time at the end. Please type your questions in the questions box throughout the webinar, and the ACI team will get to them at the end. Handouts, PowerPoint slides are provided and can be found on the right side panel, but CGNA will also include them in the marketing follow-up. Let's get started. I'm really happy to introduce industry friends Mike Bollant and Dave Weise from Automation Components Incorporated, or better known as ACI. ACI has been a preferred vendor member of CGNA for over 15 years. This company is a great example of a vendor that strongly supports the CGNA organization and has spent a tremendous amount of time and energy working with each of you to use their product line to provide growth and opportunities for your business. This company exemplifies relationship selling and quality products. Automation Components specializes in designing and manufacturing quality temperature, humidity, current, and gas detection sensors. Their tagline is engineering a better sensor solution, and they've absolutely done that. Today's webinar is on their gas detection products. They offer not just components, but a full gas detection system solution. Many of you buy and sell competitive brands. I encourage you to look at ACI's product portfolio. Thanks again for attending, and ACI, welcome, thank you, and let's begin.
Thank you, Sarah. Appreciate that. It was very nice. I'm Mike Bollant. I have Dave Weise here with me. We're going to be doing the gas detection webinar, and further ado, let's get started. So ACI gas sensors, we're a supplier of CO2 toxic combustibles for all the different gases that are currently in the market. We stock a lot of products here. Our lead times are phenomenal. Our products are very high quality and very competitive. We offer a 2-year warranty on the toxic and combustible sensors and a 5-year on our CO2 sensors as well. Some of the applications that we'll be getting into are, of course, parking garages, Freon systems for chiller plants, auto service, warehouses, battery storage. One of the big ones that's been applications that's been coming up is boiler applications, and we'll talk about that when we get into a few of the sensors that go in there. But there's a few states that are making it standardized spec-wise, that you put CO and or methane sensors in your boiler rooms. So also sewer plants and applications like that. So I'm going to start with the first slide here. I won't really get into details. I have slides that are split out that go into more details. The Q5B5 is basically a standalone or a communicating device for all toxic combustibles. The Q6 and B6 are combo units. I'll get into that as well and what the differences are. M controller and the Q controller and what their differences are, as far as how many points you can put on each controller and why you would use one over the other in different applications. The QIRF, refrigerant detection system, is for chiller plants, and we've been doing quite a few of those throughout the country, and we'll get into the systems on that as well. And ACI also offers a Q8B8, which is backnet or a straight up explosion proof type sensor. So those are becoming more and more popular, and especially in the industrial applications like chemical, petro, and gas and hydrogen and jet fuel for military plants and stuff like that. So. Okay, we'll start with the M controller. The difference between the M controller and the Q controller basically now is the difference about how many points. And usually when we get the plans from you guys to lay out a system, of course, if it's 32 digital or less, we'll probably put you into the M controller. If it's a bigger job for, say, a parking garage, say you got 60, 80, or 100 sensors and you can get away with using one controller, we'll definitely go the route of a Q controller. Both of them are RS-45 communication protocols. You can also have 4 to 20 milliamp straight back if you need to. And the Q controller right now can be set up to do backnet IP to your building automation system. And very shortly, it's in beta, it's been tested. The M controller will also be able to do backnet IP to your BAS if needed. So. Okay, we'll get into the sensors, the Q5s and the B5s. The Q5s, there's many applications you can do with this. We have to look at every job differently because of the way it's laid out. Q5 can either be standalone or it can be daisy chained to RS-45. It also comes with an LCD, NEMA 4X enclosure, horn buzzer, and it also comes with 3 pre-programmed relays on it, as you can tell in the middle. Replaceable factory calibrated sensor module. What that means is, let's say you get down the road, you've got a CO sensor, and say it's 4, 5, 6 years and you don't think it's operating right. You don't have to replace the whole unit. You can just pop the cover off and buy the replacement microprocessor board and put it in for probably 1/3 of the cost. And it's all pre-programmed. You power the unit down, you put the microprocessor in, you put the cover back on, power it up, and you're good to go. It's pretty much that simple. So can be password protected. COs all come with a UL 2075 certification on it. And once again, the people always bring up the typical lifespan on a sensor pretty much comes down to how concentrated the gas is in the area. If it's really highly concentrated and your alarms are going off all the time, it's going to wear in the sensor and you might get the 2-year. If it's more standardized and like a standard parking garage, you might get 5, 6, 7 years out of it. It all depends on the concentration of gas. The B5. B5 is the backnet sensor, backnet MSTP. Pretty much what it is. All the same features: 3 relays, horn buzzer, LCD, NEMA 4X enclosure, and also you can change the baud rates on the front using the front of the pad on the sensor. If you need to go from 9600 to, I think it goes up to 115.5 or something like that. So, and all the relays are writable via backnet. And this can be used as a, however you want it. So if you don't want a controller and you've got a say you got a BAS with backnet, you can go right on their network. We do that quite often with a lot of applications. I'll go back to the middle part here. Depluggable terminal blocks, which makes it easy to wire. Backlit LCD, TWA, STEL. All those features are included in this unit, and 24-volt AC or DC power. Any questions right now on this unit? Okay. The explosion proofs are class 1 div 1, toxic or combustible. They come with 3 relays on board, an LCD, and pretty much what you see there is what you get. 3 magnetic buttons, the threaded openings, but covers all Division 1 Class 1. Now there are some explosion-proof gases that we can't do. If somebody needs a list of those, we can get those to you, but it covers about 90% of all of them out there. Hydrogen, jet fuel, gasoline, diesel fuel, everything. So let us know if you have a particular gas and we can line you up with the part number and this feature too. Here's just here's a sheet of the, let's say, typical gases that are available. There's a lot more than this, but these are the most common. And as you can see on the left side, acetone, ammonia, methane, chloride, chlorine, chlorine dioxide, hydrogen, methane is a big one. And then down at the bottom, when you look at combustibles, you can see the various amount of different gases that can come with that part number as well that are part of the combustible gases. Ethane, ethanol, like I said before, hexane, jet fuel, kerosene, all those. Toluene seems to be a big one. VOCs, all those type of combustible gases. And it also gives you the measurement range on here, the temperature range, how many square feet of coverage area, and the radius. And then on the right side is kind of a key one too. Depends on what kind of gas you've got, whether you mount it low, high, or medium. And so it kind of helps you out as well. Just to give you an idea, let's say that you've got a gas that you should be mounted high, but you want to see it at eye level. We also have remote sensors that can go up, measure the gas, and bring it back down to the LCD part of it. And we can talk about that in another slide as well. Okay, the B6 and the Q6. This is the combo unit that ACI offers, and the reason we came out with this was to get more competitive than having individual Q5 and B5s. What we did was we took the LCD off of the second box, and we made everything visual on, let's say, for example, on the carbon monoxide, usually mounted at 5-6 feet in the air. And say an NO2 sensor is mounted down around 18 inches. Well, you don't want to get down on your knees. You have to look at the screen, so everything's visible for CO and NO2 up at the CO level. It's a scrolling screen and just keeps going, and it shows you what the parameters are for both gases. Both are come with relays, 3 relays on each, programmable. They're pre-programmed to the parts per million of whatever type gas you have, whether it's CO, NO2, methane, hydrogen, it doesn't matter. It's all pre-programmed for you. Let's see, what else? Am I missing anything on that one?
So the nice thing about having this in 2 separate enclosures is that you can use that remote, that secondary gas can be anything. It could be to measure gasoline vapors or petroleum vapors. They're normally heavier, and they're going to be, so you're going to mount that down low. Or that secondary sensor could be methane or hydrogen, and that would be mounted high up near the ceiling. Now, Mike brought up earlier about one of the fast-growing, applications that we have are boiler rooms. So you could get a combination sensor in CO and methane, so that CO would be mounted at breathing height, 4 to 6 feet off the floor, and that methane would then be mounted up near the ceiling, where that methane gas would accumulate if there was a leak.
Correct. Yep. Good point. So, all right. So we can go into the differences between a B6 and a Q6. Basically, the obvious one is the B6 is going to be a BACnet MST protocol. The Q6 is going to be either RS-45 or
it'll be Modbus RTU to a building automation system, or the proprietary Optimix protocol to one of either the M controller or the Q controller.
The one big difference between the B6 and the Q6 too is that on the Q5s and B5s, I mean, is that the B6 and the Q6s will not have any analog output. So if you need an analog output, like say a 4 to 20, you'll have to go back to the Q5s to get that. And sometimes that plays a factor in which units you can use and which ones you can't. And another big feature on the B6 is there's say you've got the combo of those CO and NO2, it only has one address for both sensors on the BACnet. So you won't have an address for NO2 and CO. You'll have one address for both, which is pretty big when you're running, say you got 10, 20 sensors on a project. You may not have to buy another JACE or whatever control system you're doing. So. You guys have any questions on this?
Hey, Mike, we'll probably save those for the end. And we can,
All right,
perfect. Yeah, we'll open up the mics for people to either post questions in the panel or just ask them.
Perfect, perfect.
Okay, great. Doing great.
Okay. Here'd be just a typical wiring diagram of a combo unit, Q6 and B6. And I'll let Dave talk about the internal parts of this.
Yeah, so again, because that remote can be mounted up higher or down low, the remote needs to communicate with the main and get power from the main. So as you can see, when it's either mounted high or low, the internal communication is going to be on the main on that left side and run down to the remote. This is just a nice, easy way to see and to visualize, how that would look out in the field. And on the upper right, where it says RS45 to controller or BACnet MST to terminal, that would be where you would run your COM bus from sensor location to location to location back to your building automation system or to one of the controllers.
Here are some accessories. Of course, in parking garages are probably the biggest thing. So if you don't want the sensors to get damaged by people backing into them or knocking them off the wall, we do have a sensor guard. We also have a splash guard, and you'll ask the question, well, why do I need that? Well, a lot of applications like fire stations and ambulance stations, what they do is they keep their vehicles pretty clean. And so they're washing them all the time. And with the NO2 being down low, and the CO being eye level, a lot of times there's water that can splash inside and get under the sensor and damage it. This splash guard helps protect that. So that's a nice feature if you have that type of application. In a parking garage, normally the sensors are located far enough inside that unless you get a hurricane, they're not going to get hit. And we also have duct mount accessory kits as well too. Replacement smart sensors. I talked about this at the very beginning. What you can do is say you've got a system out there for, let's say, a couple of years, say 4 or 5 years, and you're doing your bump test or annual calibration every year, and you notice the sensor's not reacting correctly. Instead of replacing the whole box, all you have to do is pop the cover off, and there's 2 screws in a microprocessor board shown here. You power the unit down. You take out the old, put the new in. It's all pre-programmed. Power it up, and away you go. And it's wise to do a quick bump test on it just to make sure everything's good. But they all come pre-programmed, so that's a great way to replace the sensors too. And it saves a lot of time replacing. If you have to replace boxes, especially in the service side of it or service contract. So. Gas cal kit. We offer this gas cal kit. Comes with a regulator, adapter, your poly tubing. The gas is not included. That is sold separately. We do not carry the gas here, but we have teamed with a company to get the gas. We drop ship it just because of its liability and stuff like that. But usually lead times on that are 1 week to 2 week lead times. So, and the other thing about this too is if you've got I'll talk a little bit about this, is if you've got a project you're going to go out and test, don't hesitate to call us. That's what we're here for. We can run you through how to set up your regulator, the tubing, the gas, so you can do your bump tests or calibrations very quickly. The first couple of times you do them, it'll be, it's not that hard, but it's always something new. And once you get the hang of it, you're going to breeze right through it because it is a very, very easy process. I'll talk a little bit right now. I think it's in a future slide too. What ACI has done and will continue to do is you as distributors have customers, and if your customers, we see once in a while in specifications that require a certified installer to install the gas systems. It's been difficult because some of the other competitors have been around a lot longer than we have, and they're kind of not given the support they need. So what we've offered is to certify your customers on installing our systems, and we can get a certificate for you. They have to go through, it takes probably about 45 minutes of their time to get certified, and that's about it. And we've been doing a lot of that lately too, and it's a big added feature, especially for your customers, to be certified. So I wanted to pass that along as well. Just the gas positioning thing again, medium, high, and low. Low is usually 18 inches to or 12 to 18 inches off the floor. Medium is 4 to 6 feet, and high below the ceiling is anywhere from a half a foot to 2 feet, somewhere in that range too. Gives you square footage of coverage. Same with the radius and stuff like that. Every gas is a little bit different depending on its weight. And so some of the applications here, we'll talk about parking garage. Of course, you mount your NO2 down low, you mount your CO at 4 to 6 feet. We really recommend on bigger projects, not the home run, 4 to 20 is back, because we can daisy chain anywhere from 32 digital sensors all the way up to 128, depending on the size of the job. The other thing we do, like I said earlier, is we'll take a look at your plans, we'll lay it out for you. Normally, we'll have an answer back to you with a full layout in a couple hours, which we can, which isn't that bad really for time-wise. The unique one that we run into once in a while is like your loading docks. And the reason that you may have to have your CO sensor and then an NO2 sensor high and maybe low is because these semis have, depending on the type of truck, they have their exhaust system that hits the floor, okay? So you've got to have something low to the floor. Well, it doesn't exclude the ones that have the stacks that blow the NO2 up to the ceiling. And then it comes down, and if you put the NO2 sensor down at the bottom, well, that's a hazard and might run into problems. So that's why we recommend putting an NO2 sensor about 2 feet off the ceiling. The other thing we also recommend is putting an override switch by the CO sensor. The reason we do that is we tie it into your exhaust fan. When the stacks go up, and with emissions these days on these semis, the byproduct of the diesel will start coming down, and the first thing that happens, people say, well, the sensor's not working. Well, there might not be enough NO2 and that emissions to set that sensor off. But the byproduct is very uncomfortable for people to start breathing. So we have an override switch to turn on the exhaust fan and get that byproduct out the door. And we really recommend doing that as well.
It's not necessarily the NO2, it's the smell.
It's the smell. Yep, exactly. It's the byproduct. Okay, MDU programming. I'll let Dave talk about the programming of the unit. And
Yep. So the M controller can be programmed either with the onboard keypad or with the MView software. That's included with every M controller. The programming cable is also included. If I recommend and suggest that if you're going to use the M controller, use the MView software. It's a lot easier and a lot faster and more efficient to program the M controller than using the onboard keypad right now. So when you first open it up, this is what you're going to see. On the left-hand side is where we're going to do all our programming, the sensors, the relay styles. So in this example, we have basically, let's call it 4 Q6 CONO2. We have 4 CO, 4 NO2. So when we address the sensors, we always start at 0. And with the Q6, when you do that, the remote is automatically a +1. So when we do this, all our CO are going to be even, all our NO2 are going to be odd. It's going to be really easy to remember that. The next step, we determine how many relays we're going to use. In this example, we're going to use 2 relays. So we're going to have 1 low alarm, 1 high alarm. And we're going to set that up as voting So what that means is that if any one of the sensors reaches an alarm level, it's going to turn the relay on.
Yeah, I'll touch base on this too, where on the M controller, for example, there's 3 relays. So say you got, I'll just use an example. Let's say we've got 2 floors and we've got, say, 8 sensors on each floor, and you've got 2 dedicated exhaust fans for each floor. You can latch these sensors to, say, relay 1 for floor 1, latch all the sensors on relay on floor 2 to relay 2. So only when any one of those sensors sense and go into alarm, they will turn on the fans on that particular floor. So you don't have to have both floors coming back to one relay and everything turns on.
So right here, this is where we're assigning the sensors to relay 1. And as we can look here, this is the alarm level 1. So we have 35 parts per million for CO to turn on, 25 to turn off. For NO2, we have 1 part per million to turn on, and it'll turn off at 0.8. So again, this is relay 1, and we'll go do the same thing for relay 2. This will be our second alarm level, or our high alarm level, and we'll make that concentration for CO on at 50, off at 40, and then for NO2 on at 3 and off at 1. So, once we do that, all we do is we download that into the M controller, and it's programmed. It's very, very, very easy to do.
So these are the free services provided by ACI. What we'll do for you guys is you get a parking garage, you get a boiler room, you get anything. We'll take a look at it. We'll lay it out for you. We'll recommend the parts and pieces you need. We'll take that off your plate, and like I said, we're usually pretty solid, and we can do that in a couple hours. Here would be just a typical network diagram. So for example, this happens to have a Q controller on it, which goes up to 128 digital points. We only show 4 sensors, but let's say we had 60. The RS-45 would be pretty much all the same. And then we have a back box on there that's you need to add if you want to come back to your BAS with BACnet IP. Just a typical diagram here. And here'd be, let's say we went back to the Q5 series. Let's say you had a job that you only had like 10 sensors on, you wanted to use Q5. You didn't have any other gas with it. Sometimes they don't have NO2 or methane or whatever. M controller can handle up to 32. Boom, here's your network. And we usually put together these network diagrams for you based upon every job that you do, just to make sure it matches what you need for that particular project.
Hey, Mike.
Yeah.
When will the M controller be released, or M controller 2 be released?
We've been told sometime this spring. We don't have a hard date yet.
Gotcha. Great.
Yep. And then when you give us your plans, here'd be a typical radius layout to confirm where the sensors go to make sure we got adequate coverage. We do that for you as well. And Dave Weise would be doing the training, the certificate. QEO would sign off on it when Dave said that, say your customers went through a training program, become licensed to install ACI systems.
Yeah, and the training is very simple. It consists of, I send a link out to the participants. That they're just 5 short videos to watch, total of about 20 minutes. And then we would set up a short Teams meeting to go over some PowerPoint that talks about, wiring, a full wave rectified, some of the different sensors, how they would go together, addressing, programming, and everything like that. And once that's done, we'd have a question and answer session. That's usually about 30 minutes. And, so they can, people can be certified less than an hour. And, very simple, painless, and, we don't charge anything for that.
Okay, just an overview, no charts and network diagrams. The other thing, going back to the MDU software too, that I'll mention, once you do a job, let's say you do a parking garage and it's got, let's say 16 CO and 16 NO2 sensors, and you download that into your laptop. Well, the next time you go to the next job and it's pretty similar, well, you don't have to spend any more than like 10 minutes because all it is number change. Let's say you got 40 sensors. All you have to do is address those in the system, download that. Pretty soon you've got 2 jobs. And so that's how simple it is as you keep going down the road too. Okay, that concludes this seminar. Sarah, I'm going to switch PowerPoints right here. I'm going to go right into the Freon system. And the chiller, it takes about 10 minutes, and we're going to switch out here. So.
Okay, great. Thank you.
Can you see that, Sarah?
Yes, sir.
Okay, we're all good to go?
That's great. Yep.
Okay. So the next product line that we got here for our gas detection is our QIRF refrigerant system. And that's mainly for chilled water or chiller systems and mechanical plants and stuff like that. And we'll get into the details here in a second. Okay, we do everything by the B52 spec, ASHRAE 15 code. We've got pretty much everything you need to meet the specification of a specifying engineer or the specs or the codes that are in place right now. So here's the QARF refrigeration detector, and basically it's got 3 relays on board, a 4 to 20 or a 2 to 10 output. It's got an RS-45 Modbus protocol on it. There's 3 relays that are on board, all pre-programmed. I think 90% of them are 50, 750, and 1,000 ppm. There's like R123 is a little bit different on that. It comes with an LCD display with backlit on it, NEMA 4X enclosure, covers 7,500 square feet. And the nice thing about this unit is, let's say you're a distributor and you've got one on your shelf and it's an R134A, and your customer comes in and says, well, I need an R410 or R510, no problem. If it's his first time, he can call in. He just takes it out in the field and we reprogram this to any Freon that's currently on the market. I'll show you some of them that we currently have, but there's a lot more. I guess we've got to update a little bit, but we cover probably 95% of the Freons on the market right now. And it can be used as standalone, or it can be used as a system with the Q controller or N controller. And we'll have a couple slides coming up that'll kind of explain that too. The nice thing about this unit is there's no sample tubes. There's no sample tubes on this. This is an infrared technology. The sensor life on this is 13 years. It covers 7,500 square feet, like I said, and it's extremely sensitive. And you typically mount this down between, let's say you got 2 chillers, you mount it down about 18 inches off the floor. A lot of people just mount it on the pad where the chiller is. And if you've got Freon, say you got 2 chillers and the Freon is the same, you don't need 2, especially if they're within the 7,500 square feet, you don't need 2 Freon detectors. 1 will detect the whole area, so there's no need to put 2.
Yeah, usually that would be mounted somewhere between the 2 chillers.
Between the 2 chillers, correct. Here are some of the Freons. I know there's a few more that have been added lately. If you've got one, just let us know and we'll confer. But these are all downloaded into the microprocessor that's on board here. That's why we can reprogram this thing in the field. So even if you've got one in the field that's been in, say, 5, 6, 7 years, and all of a sudden they come in and for whatever reason they change the Freon in the chiller, you don't have to redo the system. You can just reprogram the Freon or the QIRF to match the Freon that the chillers have. Really nice feature. Once again, here's the two controllers. 90% of the time, the systems we do will set up with an M controller because we haven't seen too many chiller plants that use 6 QIRFs in one mechanical room. And like I said, the M controller comes with 3 relays, relays for horn and strobes, which I'll show you in a little bit on a network diagram. However, sometimes we run into a system where an engineer, consulting engineer, will want BACnet from the system back to their BAS or in a situation like that. So then we have to go to the Q controller and give them BACnet IP. So that would be, a lot of times that's probably the only reason that we use the Q controller. For now, until the M controller comes out with its BACnet. Some of the accessories here, M switch, Q switch, horn and strobes. We'll cover all different types of strobes. We'll show you here in a slide how we wire, or like a B52 spec for that. The M switch typically goes with the M controller, Q switch with the Q controller. Reason we have those are for overrides. You need one inside and outside the chiller room for safety. In case something starts going off and somebody's inside or outside, it can override and turn on an exhaust fan. And we can also do light stacks. We don't show that here, but light stacks are also becoming more and more popular. Just depends on the application, but for the most part, these strobes and horns are more than that. Here'd be a typical chiller plant. Looks like we were talking about. You've got 2 chillers, same Freon type, as you can see here. We've got the M switch inside. We've got the strobe inside, got a strobe outside. And the reason we do the M controllers communicate back to the BAS, but it's also required on most projects to have an LCD at eye level because the QIRF is going to be mounted about 18 inches down above the finished floor. And this way they can see everything, whether they mount it inside the room or outside the room, they can see what's going on and so on and so forth. This would be another example of a Q controller that's BACnet IP. Here'd be a situation where we have 2 chillers, but the 2 chillers have different freons. And when you have different freons, you have to have a QIRF for each freon. You can't just do one and hope it works out. So kind of same situation when you get strobe inside, strobe outside, Q switches for override, and so on and so forth. Yeah, like I said, 18 inches above the floor. QRF field calibration, there's a test port on the side. We could set you up with the right freon and the right test equipment to calibrate it if it's necessary. Like I said, there's a 13-year life on the sensor itself because it's infrared technology. And it's the same thing for the Freon system too. If you've got a chiller plant, you can email us the plans. We'll lay it out for you. We'll give you the best scenario that we know and get it back to you within, most of the times, within an hour, especially on Freon detection. It's pretty simple. And go from there. And I think that's it.
Great, thank you.
One thing I do want to mention is on our website, I do have a number of videos that are available that show how to change the refrigerant on the QIRF, how to change the smart sensor board on a Q5 or Q6, and even how to set up the addressing. So, we do have a number of videos that, somebody doesn't want to call in or they really can't call in, they can just go on our website and view these videos. And oftentimes they're less than 5 minutes, so they're very short and very to the point.
Yeah. And we're here for you and your customers. We're not here just to sell product. We want these systems to go out, and we want multiple systems. So we want to do it right, and we want to work with you and help you. So feel free to call in here at any time, ask questions. That's what we're here for. That's it.
Great. Well, I just unmuted the attendees. So if anybody has any questions for Mike and Dave, we can wrap up the webinar. Rory, I know you had a question in the panel and I just sent you just a question on your question. So if you want to ask Mike.
Hello?
Oh, we might have lost Rory. His question was, can the refrigerant sensor, and it says for Wayland in freezer applications. So my question back to Rory was if that should have been another word or not. So maybe Mike, you know what he's driving at.
Well, the sensor itself can go down to minus 40 C. So to answer your question, unless you're going into an ultra cold at minus 80, you're going into something that's minus 10, minus 20, we no issues because that's what it's rated for.
Okay. And I know, Mike, you had said earlier, kind of off the webinar, is you guys have had an amazing first quarter, a lot of traction with your gas detection product line. Any comments on what's driving that? Is that supply chain? Is that codes or mandates changing? Any comment on that?
That's a great question, Sarah. I think it's kind of threefold or twofold. Some of our competition has basically fallen off the face of the earth with their customer service, getting back to people, product deliveries, and those type of issues. And we've stepped up and we're here, we take care of people, we have stock, and we're doing all the right things. And I think that's really helped us out. And our products are, they're reliable, and we stand behind them. And it's not just, there's a lot of turmoil going on in the gas sensor industry right now. And, never talk bad about a competition, but sometimes customer service, I think, is one of the biggest things. And getting product to people so they can get their jobs done.
Right. Okay, great. Mr. Walker, Kevin has a question for the ACI team.
I do. Thank you, Sarah. Kevin Walker with Wholesale Controls. Going back to your first sensor dealing with regular gas, you talked about the remote and it being addressed the same as the main. Is the remote recognized by a BMS system?
For under BACnet MSTP, yes. So for a B6 CONO2, assigning it one address will then, on the BACnet side, the objects and the present values for both the CO and the NO2 sensor will show up on your front end under that one address.
How does it distinguish the two with one address?
That's just how it's set up. I can't answer the, get into the nuts and bolts of how the BACnet part works.
That comes from
that's in the firmware.
Yeah, we can find that out for you, Kevin. No problem. But that's a firmware thing.
Second question. NO2 is very light. You show it to mount at a low level. I'm curious as to why you would. I mean, I can see accumulation starting there, but the gas is very light. So explain to me why I would put it low.
NO2, in its natural form, is heavier than air, so it will accumulate at the floor. Now, NO2, when it comes out of car or truck, it's going to be hot, so it will be lighter than air, and it will go up towards the ceiling. But as it cools, it will eventually come down. Now, we had a slide that showed the combination sensor being mounted down near the floor and another up near the ceiling. We always say, if there's nobody's saying anything or there's nothing in the spec, the manufacturer recommends mounting near the floor, but always follow code. whatever the local code is. If they say it needs to be mounted up high, then it gets mounted up high.
Thank you.
You're welcome.
Okay, most of the attendees, you've self-muted yourself, which is great, right? That was part of the housekeeping items. If anybody has any remaining questions for Dave and Mike, we've got a couple more minutes. Just also keep in mind, we've recorded this and we'll put it on the exchange as an on-demand presentation. Anybody else, or Kevin and Dave, anything in summary?
My recommendation is if somebody's installing our products for the first time, by all means, if there's any questions before they power anything up or wire anything up, give me a call. And let's make sure that we're going to do it right the first time. Make sure that's wired right, it's powered right, so that when the power is turned on, that everything is going to work right up front. There's no return calls, no return service calls, anything like that.
And then just lastly, one of the, I thought was a nice offering was your certification to our members contractors.
Yep.
Anything else additional on that process in close?
Yeah. The other thing too is if you've got customers out there that maybe you're trying to convert them to ACI gas and they're unfamiliar with it too, we can do these webinars for you and your customer through Teams or however they want to do it as well.
Great. Okay, so again, handouts. You can capture the handouts on the right-hand side in the panel. They'll also be sent to you. If that kind of ends the presentation and there's no more questions, I'd like to thank all of the attendees. Appreciate your support and participation. ACI team, excellent job. Appreciate your support of CGNA and of course our distributor members.
Thanks to everybody.
Thank you, guys. Thank you, Mike.
Everyone, so much.